Okay, we are here with some revision. I haven't done some in a while, so it's good to get these going. Um, yeah, it's been like 3 days, I think, since I revised and since I recorded one of these, even longer. Well, not 3 days since I revised, 2 days, I suppose. Basically, it was just Saturday and Sunday. I was pretty busy. Didn't get a chance to do a whole lot then, but I did revise over last week. Just didn't get a chance to record it. Kind of was doing most of it in in college or in short bursts. But this one should be a bit longer. Um, but yeah, so I'm just going to go over the carboxylic acids and esters summary notes, and then I am going to go over some questions like usual. I don't know if I should carry on recording it in the log because it's going to be a bit painful to just see and that I haven't recorded anything for like basically a week now at this point. But yeah, so we'll see how that goes. But yeah, let's start off with this. Okay, so carboxylic acids. These have the ending oic acid, but no number is necessary for the acid group as it must always be at the end of the chain. The numbering always starts from the carboxylic acid end. If there are carboxylic acid groups on both ends of the chain, then it's called a dioic acid. Ethane dioic acid. Note the E in its name. Okay. Acidity. The carboxylic acid are only weak acids in water and only slightly dissociate, but they are strong enough to displace carbon dioxide from carbonates. Okay. The smaller carboxylic up to C4 acids dissolve in water in all proportions, but after this the solubility rapidly reduces. They dissolve because they can hydrogen bond to the water molecules. Hydrogen bonding between dimer and solid ethanoic acid. Solid ethanoic acid appears to have MR of 120. Okay. I don't really understand why that's important. Okay, whatever. Delocalization. Carboxylic acid salts are stabilized by delocalization, which makes the dissociation more likely. Okay, makes sense. Delocalized ion has equal carbon-oxygen bond lengths. If the delocalization did not occur, the carbon-oxygen bond would be shorter, or the carbon-oxygen double bond would be shorter than the carbon-oxygen bond. Interesting. The pi charge cloud has delocalized and spread out. The delocalization makes the ion more stable and therefore more likely to form. Interesting. Strength of carboxylic acids. Increasing chain length pushes electron density to the CO minus ion, making it more negative and less stable. This makes the acid less strong. Propanoic acid, propanoic acid less acidic than ethanoic acid. Is less acidic than ethanoic acid? Oh, no, it's just for both. It's just a thing, I guess. Electronegative chlorine atoms withdraw electron density from the carboxylate ion, making it less negative and more stable. I just want to make sure that is a real thing. Carboxylate ion. Carboxylate ion. Yeah, okay. Just making sure I was using the right terminology there. This makes the acid more strong. Wait, let me just read that again. Electronegative chlorine atoms withdraw the electron density from the carboxylate ion. Withdraw the electron density. Oh, okay, I understand. It pulls the electron density towards itself. Make it less negative and more stable. This makes the acid more strong. Okay. Chloroethanoic acid more acidic than ethanoic acid. Interesting. Methods of preparing carboxylic acids. Full oxidation of primary alcohols. Primary alcohol, primary carboxylic acid. Okay, I need to know these. So let's see if this is one of the ones I know from my flashcard doing, because I have been doing my organic synthesis flashcards, which is very good. Sorry, Jake Lyons posted a Jules video. Um, okay, yeah, I know this one. I mean, just, yeah, potassium dichromate, acetylsalicylic acid, reflux, to make a ketone on aldehyde. I mean, except this is not that. This is alcohol to carboxylic acid, and it's not reflux. Wait, it is reflux. Yeah, because you reflux an aldehyde to a carboxylic acid. That's right. Not a carboxylic acid to an aldehyde. Almost makes that one up. But yeah, you obviously wouldn't be oxidizing a carboxylic acid to an aldehyde because that would be the opposite. That'd be reduction. You're losing, an oxygen. You're losing electrons. Um, gaining electrons. But oxidation of aldehydes. Okay. Aldehyde to carboxylic acid. Potassium dichromate solution and dilute stearic acid under reflux as expected. Hydrolysis of nitriles. It's a bit more interesting. A nitrile to carboxylic acid. A reagent is dilute hydrochloric acid / sulfuric acid. So I'm not exactly following that. Okay, so it's plus water there, so I guess because it's in solution, it's aqueous, yeah. That makes sense. They don't have to name it in the reagents. I was going to say, like, surely you need water to, but obviously you just kind of have to, it's obviously in solution, so that's a given, I guess. And it produces ammonia though, which is interesting. Ammonium ions. Reactions of carboxylic acids, so reduction of carboxylic acids to alcohols. Lithium tetrahydroaluminate is a strong reducing agent. We know that. In dry ether, yep. It says right there, conditions, room temperature and pressure, type of reaction is a reduction, and the role of the reagent is a reducing agent, as expected. Carboxylic acid produces primary alcohols, and I'm guessing it'll say aldehydes, maybe, or not. Can they not be reduced to aldehydes? I just kind of assumed that was a thing. Maybe it's not a thing. Salt formation reactions of carboxylic acids. Carboxylic, I guess it will just be reduced as much as possible. Carboxylic acids can form salts with metals. We know this from the, from which topic do we know this from? Transition metals? No. We know it from a topic. I guess this comes up in like, it's definitely come up recently. I'm not sure exactly which one, but yeah. Acid and metal, salt and hydrogen, acid and alkali, salt and water, or acid and base, I guess you should say. And acid and carbonate is salt and water and carbon dioxide. This is all known. Effervescence caused by production of carbon dioxide with carboxylic acids with solid sodium carbonate or a yeah, carboxylic acids will be what am I skipping here? Aqueous sodium hydrogen carbonate can be used as a functional group test for carboxylic acids. Yep, we know this. Oxidation of methanoic acid. Carboxylic acids cannot be oxidized by using oxidizing agents, but methanoic acid is an exception as its structure has effectively an aldehyde group. Oh, so it forms carbonic acid, which can decompose to give carbon dioxide. Wow, that is interesting. I might have to keep that in mind. Um, Reaction of carboxylic acid with phosphorus 5 chloride, PCl5. Believe that will make you a acyl chloride. Let's see. Yep, we got an acyl chloride just here. Room temperature conditions. Uses a test as well. Misty fumes for HCl, and then this one obviously is just the test for carbon dioxide, or the test for carbonate ions in general. Um, Carboxylic acid derivatives. Okay, esters have two parts to their names. The bit ending in "al" comes from the alcohol that's formed it, and is next to single bond oxygen. The bit ending in "anoate" comes from the carboxylic acid. Okay, good. Esterification. Carboxylic acids react with alcohols in the presence of a strong acid catalyst to form esters and water. Okay, we know all of this stuff. So yeah, esters have two parts to their names. Methyl propanoate, for example, here. So the bit that's attached to the oxygen is the first part, and then the larger chain here on the left is the second part, the source of the carboxylic acid. The reaction is reversible, the reaction is quite slow and needs heating under reflux, often for several hours or days. Low yields are achieved. An acid catalyst, and then the example here is sulfuric acid is needed. Is it only sulfuric acid? I'm going to assume it is. Easier to learn. Uses of esters, so sweet smelling compounds that can use perfumes, flavorings, non-toxic, not react with water. Uses solvents, put organic substances, so ethyl ethanol is used as solvent in glues and printing inks, although polar they do not form hydrogen bonds. There's no hydrogen bonded to a hydrogen negative atom. Evident. Hydrolysis can be hydrolyzed and split up by heating with acid or sodium hydroxide. So we can just see that here. With acid there, bit acid. Yeah, I mean, it's kind of a given. Um, just, you know, acid hydrolysis or alkali hydrolysis. Here's the alkaline hydrolysis, so slightly different. So we get a salt formed here, whereas this one is just the two molecules basically reform. Whereas with alkaline hydrolysis, it forms the salt and then an alcohol, but a different alcohol. Okay, so this reaction goes to completion, so this one's not reversible, not in equilibrium. The carboxylic acid salt is produced. Product is the anion of carboxylic acid. The anion is risen to weak attack binding fast such as alcohols. The reaction is not reversible. Okay, good. And now we move on to carboxylic acid derivatives. Okay, so consider the reaction. I'm starting. I mean, I was here, wasn't I? I mean, this derivative stuff. I mean, it's just stuff I have to know. I think at this point, what I should do is just get on with the questions and see where I can do. So that's what I'm going to do. Question 1. Okay. Hmm. So we're extending this chain here. Acetylation is the addition of a C double bond O. I've searched this up before. Yeah. Wait, is it? Okay, yeah. Makes sense. So it's not that. Okay, so substitution. I don't think it's hydrolysis, right? Because we're not adding water anywhere. Substitution could be potentially correct here. What are we substituting? Hmm. And transesterification, I'm not exactly super knowledgeable on that, but it could be hmm, it could be an instance of the like. I would go one of these two. I guess I'll go substitution. I think it's substitution. I'll have to look over that one. Polyesters are condensation polymers. It shouldn't be too hard, so let's just visualize benzene 1,4-dicarboxylic acid. So, um, well, A is surely the only feasible one. I mean, the carbon oxygen double bond is not going to be breaking as far as what makes sense, so I'd immediately say only A is possible. But the fact that so many are different makes me think it's not right. Hmm. Though I'm quite sure that A is the only feasible option here. Yeah, I'll go A. Oh, that's question 2A, so you have question 2B now. PHB, single monomer, which could be methyl propanoic or butanoic. Well, it's certainly butanoic. So A and B are immediately the only possible options here. and it's just a question of whether the hydroxy group is on the second or third carbon. And it's pretty clear that the carboxylic acid carbon is the first carbon, so it should be the third. Should make the answer B. Through the four compounds shown below, which of these compounds will react most vigorously with water? Well, consider the reactions of carboxylic acids here. And then we have acyl chlorides, and we have... What even is that? Is that a a amide? Yeah, C. Hmm. I'd assume it isn't A or B, but I can't speak as to whether C or D would be more likely here. I suppose looking over that stuff was useful then, huh? Let's look over it quickly, because we don't have any things to look on. So there's amides here. These are just polymers. Acyl chloride. I suppose we'd have to look at our reactions in the amines topic. So we have acyl chloride here, but that doesn't oh, it does say acyl chloride react with water. So chlorides are much more active. Well, I mean, we already kind of figured that. But whether from this being emphasized here and not for amides, I would kind of assume we're hinting that amides is the answer here. So I will go with amides. I mean, kind of hinting that acyl chloride is the answer here, so I will go with D in this case. Question 3A there should be D. Okay. Question 3B here, which forms methanol when refluxed with aqueous sodium hydroxide. I believe that is going to be one of A or B. Wait, does that make sense? Yes. Methanol, specifically, should be B. Can't imagine methanol forming from A. Oh, wait, A might make sense because it forms the salt and then it just forms CH3OH. Hmm, that's actually the answer. It's A there. Wow. C has at least one triplet in its high resolution proton NMR spectrum. Well, I can immediately see that C has a triplet. No? Like, I can see a CH3 and a CH2 group next to each other. That just means triplet immediately. They're bonded. We're going C. I think I'm gonna have to go a bit further because I think the answers are quite long, so like it'll show us a lot of them at once. So I will carry on going through these. I wonder how long it takes to get to the non-multiple choice. Oh, so they're all... Okay, yeah, it gets to most of them multiple choice, so... Which of these has a fruity smell? So, that's going to be an ester, which makes sense for none of them. So it's not going to be an ester. Because D can't be an... Oh, D can be an ester. So it's D. B. 0.01 mole of each compound is added separately to identical volumes of water. Which solution would have the lowest pH? I mean, C I immediately know is going to have a low... Oh no, high. No. Lower pH. Lowest pH. Well, obviously it's not going to be A. And obviously it's not going to be B, right? So we're between C and D here. What's a lower pH? A carboxylic acid or an ester? Would definitely assume a carboxylic acid. Unless I'm discounting B too quickly. HCHO. What's the formula there? Isn't that just a... It's not an alcohol, it's a aldehyde, right? I would assume C. I'm gonna go C. C here. Each one is heated separately with excess of sodium dichromate. Which compound reduces the largest amount? It would be the alcohol, surely. A. And it's a primary one as well. D. Highest boiling temperature. Um. Hmm. For this one, I'd assume C. Carboxylic acids have higher boiling temperatures than alcohols, I believe. Those would be my two considerations there, so that's what I'll go with. So these compounds can be oxidized by ammoniacal silver nitrate. Ammoniacal, ammoniacal. Either way, the only thing I associate silver nitrate by for now is making Tollens reagent and the test for halide ions. Um, but in terms of oxidized, I mean, I know, hmm, I know, no, wow, well, I'm assuming C and D aren't going to be as easily oxidized. There's a lot of, they don't want to, C and D are oxidizing agents, are they not? Because they want to be reduced. They want to lose electrons. So it's A or B. I don't know why I wouldn't just assume A again. I kind of was just going to assume it's A again. Might be getting all of these wrong. Question 5 here. I think maybe after this one I will look at the answers. Nucleic acid may be prepared from ethane, nitrile, CH3CHN. This reaction is best described as. This reaction is best described from as well, it's obviously A or B. Turns if we're analyzing like the oxidation states here. Well, there's a lone pair on the CN, which means it's probably gonna donate its electrons. So I suppose that means it's a reducing agent. Which means the compound is oxidizing it, so it's B, it's an oxidation. Okay, let's check out our answers now. Okay, question 1 was D, so let's just go back and check that. So, transesterification. Okay, I did, consider that. I mean, it makes sense with the esterification and then it gets hydrolyzed. Is that the thing here? Makes sense. So that was A there. And then we had AB, which were both correct. Then we had DAC, which is correct. Then we had DCA, which is correct. CA or CB here. So for E, we misidentified there. So it's B. So why is it B over A? That is my question. The answer is B here. And then for question 5, we were wrong. It was C. It was hydrolysis? I didn't even consider that. Oh, we did just check that, didn't we? Oh, that's a bit of a blunder there. Where was it? Yad. Where is it? Where is it? Wait, what? Have I scrolled past it, haven't I? Hydrolysis of nitriles. Here we go. Yeah. Yeah, we literally read that really recently. Wow. Yeah, that's silly of me. And I went through that whole process of trying to work out which it was, and it didn't actually make sense to me either. That's quite funny. Very funny there. Okay. All right. So I'm gonna quickly find out why E was wrong. That's really the only one I don't understand. I think A, I understood why that was wrong, right? Yeah, I think so. So, for E, I'm gonna go and look that up for myself, and I'll be back with it. Okay, so just gone over it, and yeah, it was pretty simple. I was right with my association with Tollens reagent.
that just is Tollens reagent, and I didn't make that association for some reason, even though I know you make Tollens reagent from ammonia and silver nitrate. I was a silly, I don't know, I just didn't, I would just assume it kind of would say Tollens reagent, I don't know. But the reason um it is B and not A, I mean, one should know that it's just B because aldehydes react, but it's not A because tolerance reagent is not strong enough to oxidize alcohols. That's just basically just what you have to know. Um, I mean, you can just know they only does aldehydes, but I wanted a bit of extra information as to why. But yeah, everything makes sense in that context there. So I think if I scroll down a bit, I just want to see if there's any more questions I want to get on with. So polyesters, I think we're pretty decent at this. This is okay. Measuring the rate of reaction. Maybe I should go over this stuff. So I'll go for question 9. Try go for this one. So colorimetry certainly would. Electrical conductivity. Can see that working there. Quenching samples and titrating with acid. Wait, why do I feel like they all could work? Titrating with acid though. Wait. Yeah, I don't think titrating acid would do a whole lot. So I'd go with C here. Just gonna check if 10 or 11 are good questions, and then I might just check the answer immediately. Ethanoic acid is not a product of reaction of. Um. Ooh, this could be a good question to answer. I'll go ahead and do this one. Uh. Hopefully this one's pretty straightforward. Just knowing my stuff. Okay, we're back here. Um. This one is lithium tetrahydroaluminate. So an ethanol reduction of ethanol. I don't think that makes sense to produce ethanoic acid. So maybe A. Ethanol chloride with water, acyl chloride. Yeah, that makes sense. Ethyl ethanoate with dilute acid. Yeah, that's just acid hydrolysis there, which would produce ethanoic acid. Ethanol refluxed with potassium dichromate and sulfuric acid. That could be. So A, yeah, A is pretty confidently our answer there, because that would produce a carboxylic acid, primary alcohol, um, goes to aldehyde, then ethanoic acid. So yeah. Um, yeah. So C is wrong. D is wrong. B as A or B, I think, but for A, this is. Oh wait. Propanone from one, propan one, oh, it's just C. I wasn't really reading the question properly. Yeah, propanone's, yeah, it's C here for 11A. B and C. Let's just do these quickly. Which test between aqueous solutions of ethanoic acid and ethanol? B, right? Yeah, B. Says for carboxylic acid there. With the thing we read before. Which test would distinguish ethanol chloride from ethanol? Yeah, D is going to produce a carboxylic acid with that, so maybe D. Let's check our answers there. I kind of went through those last three pretty quick, but okay, so we have up to 11 here, so 9 was C, so we got that bang on. Which was, what was question 9? Yeah, we got that bang on. So electrical conductivity. And then 10, yeah, we got that one right. Ethanol with lithium tetrahydroaluminate there doesn't make any sense because why are you reducing something that can't really be reduced that easily? I guess probably. Question 11 is CBD, which is exactly what we got. So kind of just did them flawless, even though I was not expecting that. So A was pretty free. B, yeah, that was pretty free because if we go back here, I don't know where we saw this. Yeah, the salt formation. So this is just that. So yeah, that was kind of free as well. And then C, I wasn't sure. I went with D because why'd I go with D? It's hydrolysis. I know it's hydrolysis of ethanol chloride, but I don't remember what the difference is. Steamy white fumes is the observation there. So that would be the one there. Okay, pretty happy with that. Is there anything else we should go over? We just saw this. So maybe C or D, sorry, maybe D. Question 13, is that the answer D? Yep, okay. Um, yeah, these are pretty simple, straightforward. I think we covered quite a lot of it here. Happy with this. So I think I'm gonna end it off there. 45 minutes, and I got pretty good spread over the topic. I'm quite happy with that there. So that will be all for this one, and goodbye.